Okay, so for this one, we're doing zeros of polynomials. Okay, so when they talk about zeros, zeros can also be called roots. They can also call it solutions. They can also call it the answer. Also, you can call those x-intercepts. So anytime we're working through stuff, if you see zero or root or solution or answer or x-intercept, they all mean the same thing. It's just depending on what mood somebody's in and how they want to write them on those days, it would be it. Um, Now, obviously, x-intercepts is graph. So if we're solving an equation, they won't talk about x-intercepts. X-intercepts will be graph. So sometimes when they're talking about graphs, they'll talk about x-intercepts or roots. More of a graphs than they do with other things as they go through those. So. Okay, now when we're getting ready, so this one today we're looking a little bit more at graphs on these. We're going to talk about the multiplicity of zeros. Or again, sometimes they call roots for these, but multiplicity of the zeros. Okay, and whenever you see multiplicity, just think power. So when they talk about multiplicity, it's the power, it's the exponent. So multiplicity is the power of whatever it is that we're kind of working through as we go through this thing. Okay, and when we're talking about all the multiplicity of this thing, and when we're talking about the powers, and here's where it is, it's based on the power of each parentheses in factored form. Okay, so the reason we were working on the factoring stuff there that we just got finished with is that the problems you do today, you're still going to have to factor these problems. And I know that's not the greatest news in the world, but you're still not done with factoring just yet. We're still going to keep working on these. So you're going to get an expression. You've got to factor it to get it down to a certain point to do what you've got to do. And basically, here's what it is. There's two things we're looking for. If whenever you factor this thing, if it has an odd multiplicity, or again, if it has an odd power, the graph at that root or at that solution so we're gonna take an equation we've got. We're gonna do some factoring on it, and after we factor it, we're gonna solve it a little bit. After we've got it set up and going through this one. Okay, so if you have an odd power on whatever it is that you're factoring, you get, and again, you'll see more of this here in just a minute. We've got to know that the graph of that point crosses through the x-axis. Okay, so if you have an odd power or an odd multiplicity, you're going to cross through. Okay, so numbers are either even or odd, so we got to look at the even part over here. So if you have an even multiplicity, or an even power. The graph turns around. At that root, solution, x-intercept, whatever you want to call it there. Okay, so odd power, it crosses through. Even power, it turns around. And that's it. So either it's kind of, just one of those things. And you'll see it when we'll look at the graphs on these and kind of give you some examples on this. Okay, and I think we mentioned this a while back. We're going to put it in here just to be on the safe side as we get some of these. If you have a relative maximum, that's any high point on the graph. Any peak, any valley. And if you have a relative minimum, that's any valley, any trough, I think is what we said. Okay, so any high point on the graph, that's a peak, that's a relative maximum. Any low point, any valley, that's a trough, that's a relative minimum as they go through those. Okay, not a big deal, but just, some of these they'll talk about some of any relative maximum or minimum. And it's easy to see it when you look at those things as you're going through those. Okay, so what we're going to do, going to give you an example, but you're going to do like 3 or 4 different things for this thing. You're going to solve x plus 3 times x minus 4 squared equals 0. Okay, so basically, now really technically there's 4 things on this one. For this example, we're going to solve it. Should have put that here, sorry. So we're going to solve x plus 3, x minus 4 squared. We're going to state the multiplicity. We're going to state the end behavior, and then we're going to do a quick sketch on this thing just so we can kind of see what's happening with it. Okay, so the solving part should be easy. Because again, this is what we were doing on the last test. You're going to take each parentheses that's equal to 0, and you're going to set each parenthesis equal to 0 by itself. So we've got an x plus 3 equal to 0. We've got x minus 4. We're going to set that equal to 0. Okay, so for this one, we'll subtract 3. Get x equals negative 3. This one, we would add 4 to both sides. We get x equals 4. Okay, so when they give you equation, most of these, first thing they're going to ask for, they're going to ask you to solve it. As long as it's factored like this is where it's going to be easy. And I'm running out of room here on this one, so I'm going to take this kind of go to the next page so we can kind of put it all together. Okay, so if y'all got room underneath this, we're going to do the rest of it underneath it. I don't have room, so I'm going to rewrite this on the next page. So let me just kind of bring this back here. So we've got x plus 3 times 4 squared. Okay, so just transferring that back over here, this is kind of what we have. We took, this is what we had, this is how we solved it, got these two answers. Okay, for the multiplicity, here's what you have to do. So for this part that we've solved, the multiplicity is just the powers. So what we're going to do is, for x equals 4, that came from this expression. So for this one, x equals 4 has a multiplicity of 2. If you've got x plus 3, it doesn't have a power, so that one basically has an understood power of 1. So x equals 3 has a multiplicity of 1. So they'll tell you x equals 3, and then you tell me it has a multiplicity of 1. X equals 4 has a multiplicity of 2. Okay, now here's what all that means, though, and that's where we go back to this part. All right, so the multiplicity. Everybody okay that 1 is an odd number? So 1 is odd, which means when they talk about this thing, it's going to cross through. Okay, we got the reddish pink there. 2 is an even power. That means it's going to turn around. So since 2 is even number, that means it's going to turn around. Okay. And then I think yesterday, no, 2 days ago, we were talking about the degrees and all the stuff with that one. To get the degree, you're going to add your multiplicities together. So this one had degree 1, this one had degree 2. So for this problem, it's 1 plus 2. So that's 3. So for this equation that we're working with, it has degree 3. Which means that would make it a cubic polynomial if we look at it for that part. Now in this case, I'll probably just ask for the number. All right, now here's where we get to tie all this stuff together. So we solved this one to get -3. We solved this one to get +4. We know that this thing is multiplicity is 1, so it's odd. It crosses through. This one's 2. It's even. That means it turns around. And if we add all the multiplicities together, that tells us what this degree is. Here's where we got to go back to our notes from a couple of days ago. So for this chart, it says based on the degree, we got to figure out what the leading term would be if we go through this thing and figure out what all the stuff is. So this is where we get to do our up-down thing, what we're doing back here. The only bad thing about this one is that it wasn't all together, but we know it's degree 3. So no, that's going to put us as an odd degree. We just need to figure out if the first term is going to be positive or negative for this thing. So if we go back up here and we did the full method, did all the stuff we were working on. If we do x times x, everybody okay that would be a positive x? Okay. So for the degree on this one, we got that one. We know it's going to be a positive number and then x to the 3rd power. So if we go back to our chart, it's positive x to the third power, that means the left is going to be down and the right side is going to be up. Okay, so instead of being up, down, this one's down, up. All right, so here's what we're going to do. Here's how we're going to sketch. And again, sketching the graph on this one. Here's what we do. Okay, so what we're going to do, we know this one is x equals 3, so we get to put a dot at -3. The other answer we had was x equals 4, so we can put a dot at x on the 4 on the x-axis. Okay, so the solutions, if we're graphing those, once we do, we get x equals those numbers, that's the points where they're going to cross over on the x-axis on the graph. Okay, now here's where we tied, and this is where we tied this in the other day. So here's where this is going to go. Once you solve this thing and you've got these two things, after you go to the left solution, the left point right here, because you got your 2 or 3 dots where you got it. You go to the left one from number 3 right here, which is the one on the left. This graph has got to go down like that. And where you've got the right side is up, you go to the 0 that's on the right side. You go to the dot that's on the farthest on the right, and from there you make it go up. And that's where we're tying it. I know we talked about it a couple of days ago. That's where we actually get to tie this thing together. So go to the left 0, it goes down. You go to the right 0, it's going to go up. Okay, and here's where we get to use this part back up here. So at x equals 4, this thing was even. We said the graph is going to turn around when it gets there. So for this graph, it does not cross through. It has to turn around and bounce. So now it's going to turn and go something like this. Okay. Now, and for what we're going to do, we're not going to worry about it as much time because we don't have enough time to actually dig in all the details on this one. We just know this thing is eventually going to turn and go up here. If we need to know exactly where it was, we'd plug in like x equals 1, x equals 2, x equals 3 until we figured out exactly what this graph looked like. We're just going to do a rough sketch on it. And if you notice back here at -3, it said this time it crosses through. So when we do -3, this thing doesn't turn around. It keeps on going this way so that eventually these two things will turn and meet somewhere up there. Okay, and that's where we're tying all that stuff together. That we're taking all the pieces of it and putting this thing together till we get this complete graph that we're looking at. All right, so for example 2, we're going to change it up just a little bit. Okay, so let's go with that one. And we're going to do the same thing. We're going to solve it, find the x-intercepts, do the multiplicity, tell the end behavior, all those things we did on the last one back there. Okay, and again, the very first thing we did on the last one was we were going to solve it. So that'd be, should have did that back there. So this will be part A that we're going to solve it. And with all this solving stuff that we do, when you solve these things, it's got to equal 0. So the very first thing is we're going to move all this stuff back over here. So we're going to move over the -5x to the 4th. Okay, and since that's x to the 5th and x to the 3rd, x to the 4th will go in the middle because we still want it in standard form. You still want it in descending powers. So that'll be x to the 5th minus 5x to the 4th plus 4x to the 3rd equals, and we got that -2x to the 3rd hanging out over there. Okay, and then we're going to go plus 2. So that's gone. Now we've got x to the 5th minus 5x to the 4th plus 6x to the 3rd equals 0. Okay, so in these problems, if they don't ask you to solve, if they ask you to solve it, if it's not equal to 0, you got to rearrange it so it does equal 0. Now, here's where it's a little bit easier for some of the parts we were doing. It's x to the 5th. So for this one, you know it's degree 5. Yeah, because we got this thing right here. So that's kind of the good part about this one is if it's degree 5, it's written like this where it's not factored, it's easy to find the degree. You put the highest power first, and we've got it. And again, with it being degree 5, this thing is a positive x to a odd power. So we go back to our chart. It's a positive x to an odd power. It's the same thing we had on the last one. It's going to be down and up. Okay, so we kind of jumped ahead and got the degree and the end behavior first, but that's okay. Okay, so when we solve it, here's where we get to practice, and that's why we practiced a little bit of the factoring. Okay, so we've got x to the 5th, 5x to the 4th, 6 to the 3rd. If we're going to solve this one again, we're still going to solve by factoring. First off, what do they all have in common? They all got x's, right? So we can take out the smallest amount of x's, which would be x to the 3rd. So this one, we take 3 x's out, we've got 2 left over. Take 3 of these out, we've got 1 left over. You take all 3 of those out, you've got just the 6 that's there. Okay. And that one is almost the exact same thing we did on the bell ringer because it's basically like number 2 that we took out a w, we had all this stuff left over. This one's the same thing. We took out this x to the 3rd. Now, and here's where you got to be careful. You got to have the factors of positive 6, where the sum is going to equal negative 5. Okay. And that one you got to be careful because with positive 6, you can do 6 minus 1 or 1 minus 6 and get 5. You can also add 2 and 3 together and get 5. So it could be 1 and 6. It also could be 2 and 3. This one's all going to depend on the signs for this one. But the signs make all the difference in the world here. Okay, B term is negative. So we know the bigger number has to be negative. If you divide a positive and a negative, it makes the other one also a negative. So if it's negative 1, negative 6, that would be negative 7. That won't work. It's got to be negative 2, negative 3. So we got this x to the 3rd on the outside. Then on the inside here, we're going to have x minus 2 and x minus 3. Okay, so we said each piece equal to 0. So x to the 3rd equals 0 is still just x equals 0. For this one, we'd add 2 to both sides, so it'd be x equals 2. This one will add 3, we get x equals 3. Okay, so there's our solutions. That's our roots. That's our x-intercepts. That's whatever you want to call those things. You know, roots, solutions, answers, x-intercepts. It's all the same thing, just never how they say it. It's just a little something different.
So why do you have to do x cubed?
What's that?
Why do you have to do x cubed?
Oh, because it's still, if that was just, like an x out there, it's still x equals 0. Because you can think about that one with the greatest common factor. You can still think about it as being in parentheses like that. Okay, so we've got our solutions, which when we graph them, that'll be our x-intercepts. Here's where we need the powers. This one has degree 3. So when they talk about the multiplicity here, this one would be degree 3. This one doesn't have a power, so that's understood first power. This one also doesn't have a power, so it's also going to be the first power. So if it asks for multiplicity, it's just 3, 1, and 1. Okay, and then the next thing we need with that one to kind of tie it together is all those numbers are odd. Got to figure out if they're even or odd. They're all odd. So that means that each one of these, with being odd, we go back to that and we said each one of these is going to turn around. So it turns around, and turns around. Oh, wait. No, sorry. It doesn't turn around. Sorry. It crosses through. My bad. Just thinking one thing, saying another. If it's odd, it crosses through. Doesn't turn around. My bad. So all those should be crosses through. Sorry about that. Even, it turns around. Odd, it crosses through. Saying one thing, thinking the other. Okay. Almost done. Okay, so our solutions were at 0, 2, and 3. So there would be 0. There's 2, and there's 3. All right, and then way back up here, we said, I'll go back real quick. The left side goes down, the right side goes up. So go to the 0 that's on the left, and from everything on the left, it's got to go down. Go to the 0 that's on the right side, it's going to go up. And you may be saying, what about the one in the middle? Because we didn't do anything with it. Well, that's where we get to do this part back here. This is where that odd multiplicity, that even multiplicity tells us what to do. So every one of these, it's going to cross through. So after we've got the end behaviors, when we go to 3, this says this one crosses through, so it keeps going this way. And then eventually it's going to turn down here somewhere and come back to this point. At 2, it was also odd multiplicity, so it's not going to turn around here. It keeps on going through. And at 0, it was an odd multiplicity, so it crosses through. It keeps on going that way. And then eventually these two things will keep going until they meet somewhere up here. Okay, now exactly where these go, that's they have a thing they call intermediate value theorem that we would do. We're not going to worry about that one. Basically, on Math Excel, if we're going through these, even on the test questions, there may be one that you might have to graph, but most of these will be multiple choice that you just have to pick out the graph that looks the closest to that one for what it's going through there.